Hi, the question is find the root between nodes. Given a directed graph, design an algorithm to find out whether there is a root between two nodes. Well, we can do this by using graph traversal algorithm like depth search or breadth search. In this case, since it's a directed graph, there's a possibility that the graph points back to the root of the tree. So we could, so we need to add a data structure to save the visitor node. In case it happens, we could ignore the checking. So here's what I'm going to do. Use depth search to find the path and use a data structure called use maybe a set to save visitor node. In case the node is visited, we could ignore that. So we could implement the depth search by using a stack to save the neighbor or next nodes. A stack is a first in last out data structure, and we could so if the set also we could check if the start node is equal to the end node. If that's the case, it means we find the path. So if start node is not equal to the end node, we could check if is already visited. If it is visited, we could ignore that. If it's not, we could add that to the set of visited nodes and continue the searching by pushing the neighbor node to the stack. So yeah, we could start coding here. We define the function depth search. It take a graph, a start node, and an end node. We need to create a data structure to save the visited node, and we need to create a stack to save all the neighbor nodes. The stack could be implemented by using a list in Python, and we could set the first element to start. when we begin it. So whenever there's an element in the stack, we could keep searching. And the first step we need to do is to pop the stack and assign it to node. If the node is equal to the n, we can just return true, because we have already found the path. If node not in the set of visited, we could add it to the set. At the meantime, we could continue the searching by pushing its neighbor to the stack. Extend. Okay. The exit condition of the while loop is when the stack is empty. In this case, that means we cannot find the path from start to end. So we return false here. So we could test the function out by creating another function, DFS, and then move the graph nodes 1 and node 2. We can try to compile it and see if it's passed. Okay, visited the node not in visited. The if node visited is a set. Visited is a variable, it's not a function. And then in here, graph nodes extend map points. Okay, pop is a function, should be a function instead of a method, instead of a variable here. Okay, so let me recap what I've done. So in the algorithm, I use depth first search to find the path from start node to end node. And I use an data structure visited to save the node that has been visited, because there's a chance the directed graph was pointing to the root or the upper level of the tree. In this case, we need to ignore the checking. And during the search, I push the start to the stack at the beginning, and then I loop through the stack and I check whether it is reached the end or not. If it's reached the end, I return true. If it's already visited, if the node has already been visited, I ignore the checking. And if the node is not visited, I add that to the list, and I push it to the stack for the next round of checking. If we cannot find any path from start to end, we return false. Hope it will help your understanding the questions, and see you. Bye bye.